In this statistics lesson, we're going to talk about our measures of dispersion. This talks about how our data is dispersed. So when we define the word dispersion, it's how the data is spread about the mean. So when we talked about measures of center, we focused on the centers of the data. So our median, the center of all of our data, or our upper and lower quartiles, the center of each half of our data. But when we talk about measures of dispersion, we're talking about how the whole data spreads about the mean, so how it compares to that mean. There are three measures of dispersion. First, you have the mean absolute deviation, also known as the MAD. And the equation to calculate that is what over here to the right. The definition for your MAD, or mean absolute deviation, it is the average distance of each value from the mean. So basically, what you're doing in the formula to the right is you're finding the difference that each value is from the mean and then averaging them together. Our next measure of dispersion is your standard deviation. And the equation we use to calculate that is to the right. The symbol that we use for standard deviation looks like this. What standard deviation does is it shows us how the data deviates. So that's where we get the word from. How it deviates from the mean. And we use standard deviation a lot when we're using a bell curve. And we'll talk about that a little bit later. The last measure of dispersion is your variance. And your formula for variance is over here to the right. And variance basically is your standard deviation squared. Exactly what variance is and how we used to analyze, we talk about a little bit later. But the definition for variance for now is simply the standard deviation squared. So let's look at some data and look at how we can calculate these three measures of dispersion. The first data set we look at, and these data sets are going to be pretty small. We have -10, 0, 10, 20, and 30. And you can see over to the right, we need to calculate the mean, MAD, standard deviation, and the variance. So first, let's calculate the mean. Remember, to calculate the mean, we add together all of our values and divide by the total number of values we have. And we have 5. So that would be -10 plus 0 plus 10 plus 20 plus 30, all divided by 5. Well, our sum equals 50. So 50 divided by 5 gives us a mean of 10. Next, to get our MAD, we're finding the average each value is from the mean. So we're still finding our average, but before we find our average, we have to find the distance from each value to the mean. So my first value is negative 10. From negative 10 to positive 10, if you think about those two numbers on a number line, there's a total of 20 values between those two numbers. Plus, our next value is 0. So 0 compared to our mean of 10. On a number line from 0 to 10, that is 10 units away, so plus 10. Plus, our next number is 10. 10 compared to our mean of 10 is 0 units away. Plus, our next number of 20. 20 compared to 10 is still 10 units away. And then 30 compared to 10 is 20 units away. And all of that divided by 5. So when we add together those distances, we get 60. And 60 divided by 5 is 12. So our MAD is 12. Well, the good news is Desmos or your graphing calculator calculates all of these for you. You should be able to calculate mean and MAD by hand, but your calculator does it for you. Standard deviation and variance is done in the calculator. So let's switch over to Desmos. And just like I did with my previous lesson, we're going to put that data in parentheses. So working with the same data set of negative 10, 10, 0, 20, and 30. And just like we did in our previous lesson, when we go to function and stats, you can see that we get some options for standard deviation, for MAD, and for our mean. Those three will be calculated for us. So starting with our mean, just as a refresher, I know we've already done it by hand, but just as a refresher, if we put our cursor in front of our data set and we click mean, and remember it only wants one parenthesis, you see it calculated that mean of 10 that we already did. Now if I take that out and then go to function, and if we calculate our MAD, so MAD is in that second column, 4 rows down. Put MAD in front of your data set, take out the extra parentheses, and you see it calculated that MAD, or that mean absolute deviation, of 12 for us. Now go ahead and take that out, and then our standard deviation. So when you go to function, we're tempted to put in the standard deviation that's in the third row, third column down, or third column, third row down. You want to use the standard deviation that is in your first column, 4 rows down. STDEVP. So you want the one that has a P on the end. Then when you take out your extra parentheses, oh, I took my P out. You see that we get a standard deviation of 14.1. So we're going to round that to the nearest tenth. So our standard deviation in our notes is going to be 14.1. Now your variance, it's not going to calculate it for you, but that's just your standard deviation, that 14.1 squared. So if we go back to Desmos and we type 14.1 squared, we get a variance of 198.8. So our variance is 198.8. So again, you do need to know how to calculate your mean and MAD by hand, but your calculator will calculate mean, MAD, and standard deviation for you. The variance, you just take that standard deviation and square it in your calculator. Let's look at another example. So set B, 8, 9, 10, 11, and 12. So we're going to start by finding our mean. So we're going to add them together and then divide by our total of 5. So 8 plus 9 plus 10 plus 11 plus 12 divided by 5. We know 8 plus 9 is 17. 10 plus 11 is 21 plus 12. So 17 plus 21 plus 12. That gives us 50. And 50 divided by 5 is 10. So our mean in this example is 10. Next, to calculate our MAD, we're going to use our original values, 8, 9, 10, 11, and 12, and compare it to our mean of 10. And we're finding that distance. And remember, distance is always positive. So on a number line, if we think about the distance from 8 to 10, that is 2 units. Plus the distance from 9 to 10 is 1. The distance from 10 to 10 is 0. The distance from 11 to 10 is 1. And the distance from 12 to 10 is 2. Divided by our total number of 5. So when we get our sum, we get 6 divided by 5. And we do want to divide this out to get a decimal of 1.2. 6 divided by 5 is 1.2. So our MAD is 1.2. Now, if we go over to Desmos and we put that data in, so in parentheses, 8, 9, 10, 11, and 12, we can double check that mean that we found by hand. And I do see that I get a mean of 10. And then we can double check that MAD. Remember, take out your extra parentheses. And I did get a MAD of 1.2. So again, mean and MAD we need to be able to do by hand. And then you can double check it with the calculator. So I should be able to see your work for mean and MAD. So we're going to take that out and then find our standard deviation. So remember, using the standard deviation that has the P in it. And we see that we have a standard deviation rounded to 1.4. And then I'm going to go ahead and do 1.4 squared for my variance. So then my variance I see rounded is 2. So going back to our notes, our standard deviation was 1.4 rounded, and our variance, 1.4 squared rounded, is 2. Let's take a look at one more example. Set C. So again, starting by finding our mean, we're going to add together 1 plus 3 plus 12 plus 15 plus 19 divided by 5, because I have 5 total values. When I add those together, I get 50 divided by 5 is 10. Now, it may seem that your mean is always 10, but that is just a coincidence for these first 3 problems. Next, we're going to compare each value in our set to that mean of 10. And that's going to help us find our MAD. So the distance from 1 to 10 on a number line is 9 units. Plus the distance from 3 to 10, that's 7 units. The distance from 12 to 10 is 2 units. The distance from 15 to 10 is 5 units. And the distance from 19 to 10 is 9. And remember, these are all distances, so they should all be positive. And that's divided by our total number of values of 5. When I add those together, 9 plus 7 is 16, plus 2 is 18, plus 5 plus 9 gives me a total of 32. And 32 divided by 5, we want a decimal of 6.4. So our MAD is 6.4. So now we're going to go over to Desmos, and we're going to type in that data. So that same data set in parentheses, 1, 3, 12, 15, and 19. And then I'm going to go ahead and double check my mean. Remember to take out that extra parentheses, and I do get 10. And I'm going to double check my MAD, taking out your extra parentheses, and I do get 6.4. So now I'm going to calculate my standard deviation, making sure we're using the standard deviation that has the P at the end, taking out our extra parentheses, and rounded, I get 6.9. Then I'm going to go ahead while I'm on this screen and calculate my variance, which is that 6.9 squared. And again, rounded, that's 47.6. So back to my notes, I got a standard deviation of 6.9. And then 6.9 squared gives me a variance of 47.6. So as a review, mean and MAD, you should be able to do those by hand and then checking those in the calculator. Standard deviation, your calculator is going to calculate that for you. Then variance, you're going to take that standard deviation the calculator gave you and you're going to square it. On the next page, if you will just highlight the word practice, and if you will complete 1 through 5.